introduce our next speaker for the day, may I now request Mr. K. Hema Prasad, Council Member, IAF Chennai Chapter, to introduce our speaker, Mr. Pokala Srikanth, GM Project Planning, Ashok Leyland, to our esteemed audience.
Good afternoon. It's my immense pleasure to introduce today's speaker, Mr. Pokala Srikanth. He is mechanical engineering graduate from SC University and postgraduate in tool, die and mold design from Central Institute of Tool and Design. His totally is having experience of 32 years, including Ashok Leyland, Hindustan Motors and Sundaram Clayton. His experience in functions like machine design, manufacturing, project planning, critical outsourcing, supply development. His core strength is design of lean and agile manufacturing, fuel engineering, analytical problem solving, TPM and TQABM. His achievements are Chairman's Award for BS6 engine development, the Machinist Super Shop Floor Award, hat-trick for world-class manufacturing. He is establishing P15 DOST engine machining line for bringing Japanese technology at Indian cost. Part of establishing all women's line at P15 assembly model. Now the floor is yours, sir.
I will while away sometime while it gets connected. I think after a lot of experience, speakers have spoken about the Foundry technology and all. My passion towards Foundry started when we had problems in our machining components, wherein some dimensional variation, allowances, and some Foundry defects were there. So why such defects are happening? Why these Foundry guys are so adamant on not solving the problems? So let me go to Foundry and see that in Gemba. So I went to Foundry and I saw that the process and all. My God, it was so tough to make the casting. See, I thought it is simply some sand will be mixed and they will pour the metal and they come out a good component. So why they are struggling? I was thinking like that. So when I went into the Foundry technology and the way, it's more about art. Then one senior told me, so Foundry is more about 50% technology and 50% art. Even whatever is the technology you have, if you convert into a beautiful art of making, so then it will be a wonderful product what we get. So with that starting lines, I will take to the presentation. I will take through my experience, what I have with me in machining lines. I have been basically a hardcore machining man with a process planning experience. So I will take you through the adaptation of such technology which is available in machining areas to the Foundry areas. Why not we do? So with that lines, I will go through this. So this is today's topic is innovative pick and place system for exothermic sleeves in SGRM parts. This is Ashok Leyland vision to be top in global player. So and our purpose is transforming lives and businesses through leadership in mobility. So we have our values. By the way, this is our 75th year of anniversary of Ashok Leyland. We are celebrating in a big way by sending our vehicles to across the country to know about our product and how we are serving the nation and transforming the lives. So today's topic is the exothermic sleeves. So to introduce exothermic sleeves in automation system for without compromising on cycle time. This is our objective. So we have this challenge of this preliminary mainly at Ashok Leyland Foundry division at Sriperumbudur is a KW moulding line and a current capacity of 225 metric tons per day. There is a need for modular business program. We need to have SDRN parts. What is the modular business program for Ashok Leyland? I dwell a little bit on that. It's Ashok Leyland has started a new range of vehicle platform. It is called as Avatar range, which is a modular business program. If you have seen the small toys, children are playing with the toys. There will be Lego concept where you stack up pieces to make different shapes. So the pieces are standard. So whatever shape you want, you assemble in different fashion and you get different elephant, you get a parrot, you get a train, whatever you want. It's a Lego concept. So and similarly, if you go to a pizza store, if you want to order a pizza, you have a menu where you have different sizes of pizza, different layers of the topping, and different ingredients, further ingredients. So you just order onto that, you will get the pizza delivered in the next counter. So similar way, we have wanted a dealer customer experience where We will be giving the customer the choice, going at a dealer place, press 10-15 buttons of whatever options you want, road condition, load condition. You press that, you will get a vehicle what you want. He can place an order. Once he likes it, it goes to a manufacturing line and it goes to a sequence of manufacturing. That is the concept we introduced in 2020 when just COVID was about to start at that time, pandemic. So it has picked up in a big way that we are almost getting orders into the 30% of our ordering is in that concept. Our customers are feeling happy because they are getting the product what they want. Instead of we give something, normally traditionally we give this thing, they have to choose. Here he is choosing and we are making as per his choice. So that part, so we have 3 products in that vehicle concept, that is Nodo bracket, ATS bracket and bogie bracket. So why long SGRN products in trucks? Traditional design is the extended members and all we use. There are additional features, engineering cross members and all. In modular business program design, we have a standardized design for all the vehicles, as I told. Standard for all road conditions, it will withstand that. And multiple mountings and a single bracket, that is the main advantage. You have so many fittings coming into this. Then better stack up tolerances. Because you have an integrated member, you have a better stack up tolerances and it will help you in better vehicle rigidity. So this is one example. What we are saying is a Nodo bracket, which is having a critical bending stiffness, will take a reverse load, better fatigue, better modulus of rigidity. These are the examples what I shown you. This is a Nodo bracket. There is a ATS bracket supporting the after treatment in vehicle. Then we have a bogie bracket, bigger element, which is almost weighing 500 kg. This is a typical Nodo, Eco Nodo bracket. It's the arrangement in the mold box. Different types of sleeves are there. This is the arrangement what it looks like. Now I think all of you, I need not tell, this is made just for understanding what is the exothermic sleeve. So exothermic sleeve is a moldable material in the risers. So and you see that exothermic reaction, it melts and keep the hot metal intact, and it flows, so maintain the temperature and flowability. So this is thus eliminating the casting defects. Mainly you use for casting defects. So while we introducing this, we see in SGRN parts whether all our lines are ready. So we have checked in the molding, mold making area. So sleeves are to be added. So when I am placing this sleeve, I have a challenge of traditional machine cycle time of 47 seconds to 83 seconds, 87 seconds theoretical time. It's increasing. There is a challenge. We have a magnesium treatment, metal treatment. We introduced a innovative wire feeding system, which is solving the problem of magnesium treatment. On the pouring equipment, whether we have a separate ladle for SGRN pouring, we have tied up with the interfacing because we need to pour and we need to interface with the molding machine. So with the OEM support, we are able to do that. And in fettling, we have a separate area, so it is nothing to do with the regular process. With all these things in mind, see in the existing molding KW machine, the sleeves which have to be placed on the machine by compromising on the safety and placing onto the drag. So we have, it is a regular running line. Please understand, it's in a day we will be running a GCI, grey cast iron, as well as SGRN we have to run. The first time when we introduced, so and you have to go intervene and you go in to place the sleeves on the line. It is a safety compromising thing, as well as more time is taken. See, more than the safety also, safety is paramount importance. The time taken is very high, so you have to stop the line for a longer period. And so that is, with that in the background, so we have plotted down what all the activities involved. Let us see that. So against the activity, as a planned requirement of 45 seconds, we are going up to 87 seconds. So which is more than 93% higher. Because of that, what is happening? We have a grey cast iron requirement of 45 seconds. In SGRN is going up to 87 seconds, and the capacity dropping down more than 50%, around 50%. So, and more than that, I told you about EA index. EA index is a Ashok Leyland standard, efforts and ergonomic index. We have an index which will show about how much effort is required by the operator and how much ergonomics is used in this operations. So that index has gone up to 150, lower the better. So from 150 it has gone up to 8,500. So we have gone with a regular problem solving escaper. This one, for those of you who are not familiar, is various methods of used for simplifying the operations, like eliminate. Can you eliminate some step, whatever the process steps previously are listed down? Can you simplify? Can you combine? Can you automate? Can this activity be done in a parallel way? And can you rearrange this system, whatever the system available? Out of these things, we found out that in a particular area where I highlighted yellow color, there we are having the scope for improvement. So we have done a manual activities such as spraying and placing the sleeves can be looked into which can be done. Can it be done offline without stopping the molding line? When you have done that, we have come out with a brainstorming idea from the team. Can we eliminate? We just questioned. Can you, like earlier somebody in the previous speaker, can you ask without additives, without resins, can you do the mold making? Yes, we can do it. So similarly, we asked, can you eliminate exothermic sleeves by design? Similarly, robotic pick and place, can we do it? Can we do some other automation? So we had these ideas. So when we gone to the drawing board, we found out that these thin sections are not available, they cannot be modified because of these critical design factors. See, these trucks are designed, as I told you, in modular. When you are having a heavy load, I cannot design for a lower load, and then when heavy load comes, this bracket will fail. I don't want it to fail in the field. So we cannot modify, the compromising is not there. So what else can be done? Can the design of gating be reviewed? Can we optimize the number of sleeves? Can we combine the sleeves? Can we reduce the size of the sleeves? Can you do alternate material be suggested? So then we done the magma analysis and we found out the hard zones and all. We found out that, okay, we can optimize maximum. My design department told me we can do maximum of one sleeve can be reduced. So what else? So they have given this design. So this will definitely reduce the operating cost because one sleeve is costly. All of you know that exothermic sleeve is very costly process. So, but it cannot reduce the cycle time. So we've gone with a robotic pick and place system. Okay, so this molding machine is there, so it can pick the sleeves from storage area and place onto this. What we found out is a very good solution. Faster placement of sleeves, completely automated, integration is possible, operator safety is 100% ensured. So what are the negative points? Still the cycle time is high because when it is there in 18 seconds, 20 seconds, we need to place this pick and place that. So we found out that overall for one cope and drag it is taking 75 seconds against my planned 45 seconds. So more space is occupied and it is also going into the gangway which is working space. Robo needs a protective place. You cannot take the chances. Sometimes it malfunctions, you have to go into the backside, so you cannot compromise on that factor of it on the robo. Nowadays robos are coming with that factor also where you can define the working zone, but still maintenance can override it. When you are doing a maintenance, something can happen also. So those type of things we need to take. So this automation reduces EEI, but cycle time cannot be achieved to the planned levels. So what are the automation? Can we know we don't have any other choice. We have to go for automation. What are the OEM has told, sorry boss, I don't have such technology with me. I had done somewhere in Germany. I heard the Indian counterpart told, I heard that somewhere in Germany it was done, but we don't know. So second thing is there is no similar experience in other foundries also, whatever limited. Then automation houses. Lot of automation people come to you every day. We do this automation, that automation and all. So when we approach, sorry, we don't have that experience in this, we can attempt. We are ready. So we need to have in a brownfield project, we need to have assured solutions, then we can take the risk of going to automation solution provider. Whereas in this case, I am having a person who will tell that I will do it. But at the end, if he doesn't have the experience, I have to, at what cost I do this automation. So I have to be very careful. So when we want to this, our team has, let us transcend to the level. We have pursued OEM. Let us see, we will take the risk. So this is the biggest point. We take the risk. Let us go ahead. Then encouraged in a collaborative work. We will collaborate, we will share our knowledge. You put your knowledge and take this. So, and use of AL expertise. Ashok Leyland is having, as I told you, we have our own team who does the day in, day out automation in many of the manufacturing lines. So why don't we leverage that experience? So we have gone with that one. So let us co-design the system. With the OEM, we have asked them. Then as a result, we have pursued the OEM. Yes, they have agreed, yes, we will take it forward. And design verification has been done for effectiveness. Multiple iterations we have done it. It's not that just like that we do that one and all. In fact, if you see molding machine as a Factory Safety Act and all, if you see lot of fencing is required. A lot of areas need to be protected. There are a lot of moving members apart from the moulding machine, input conveyor, output conveyors and all. So how to place this pick and place in that area? It's a very big challenge, and we have to do a lot of drawing board activities to come to a proper design shape. So we have involved in this process. So we thought of different mechanisms, whether servo mechanism will work, whether the hydraulics can be arranged. Then finally we gone to the pneumatics, because in the pneumatics is the one where this has to be precisely placed, and it should not crush the sleeves by any malfunction also. So that type of design we have tied up with the OEMs like Festo and SMC people. So they have come and they have participated in our design review initially, even before ordering. I am telling about this is all the things before ordering. Then verification of interlocks. While we are doing this, we don't want at the end moulding machine KW to say that sorry, we checked our PLC, this integration is not possible. So we have done upfront verification with the OEM. So these are the things. Why I am emphasizing all the things is these are the some of the things which you need to do parallelly before you implement a solution, before you come to a conclusion, even before ordering. That will enable you to sail through the total process and crush the customer lead time. Many times the customer want in 2 months, 3 months. How do you squeeze those timelines if you go in a sequential way? So this is a one we automation. We thought we gone ahead with pick and place. The operator is now placed here, so you can move it forward. I will show you better in the next view. So there is a pick and place mechanism. The yellow arrows indicate how the sleeves are placed in a convenient position for operator outside, where you will be picked up by the gripper. It will move to the inside the moulding machine, and it will place there. So and then it goes back. So this is a very good mechanism. So we were happy that we come to the solution. So we have done the cycle time mapping. Again 45 seconds, we found out 62 seconds. So here is the question. Grey cast iron 45 seconds, SG iron 62 seconds is okay. Management said okay, the low volume is there, you can go ahead. But what if the volumes increase? I am compromising 45 to 62. Those are daily working on moulding line. You know that this impact how much it costs on productivity. You are going to lose heavily on the tonnage. Your top line and your bottom line, everything is going to be impacted. So what we have to do? We have to bring, we don't have any choice that we have to bring to 45 seconds. Here is the challenge, the critical challenge. You have done the automation and you have got a solution ready, but you are not able to implement. So our team has again gone with a brainstorming session, again same technology being adopted. Now we have put the automation steps in between here so that we can map against what can be done. So again team has come up with ideas. So we have done a brainstorming. Can sequence of activities, can we change them a little bit? Can the travel distances anywhere, the distances can be reduced, minimized, so that we can have better cycle time? So then we have options arrived. Can we do some offline activities, online activity, can it be done offline? Can we combine that, like spraying? Spraying can be combined with while movement is happening. Can we do like that? Then reduce the travel distance and pre-positioning. Can you keep it everything ready and ready just to feed inside? So these are the three further ideas came up, which were not thought about. So there is a start position, there is a final position. So what we have done is, there is an intermediate position. We have placed, pick up the sleeves, place it and move it to inside. Because this is automation system, it can go to inside also. I don't have any interference with the moulding making. If it is a human being, you cannot enter there. Whereas in automation, you can have that liberty of going inside and wait there. Then, so pre-positioning of sleeves. Then when the cleaning die moves, track side moves outside, and you clean the portion for the residual sand, and your spraying and all can do parallelly, you can just go and place it. So by this time what is happening is your next is loading. You are not shown here, but the next set of sleeves are placed into the pre-fixture, which is outside available and ready for the next cycle. So this type of thing has ensured that pre-positioning is possible, sequence of operations, no disturbance, no interference in working zone, safety of operation is guaranteed, cycle time verification also done. So we have the curtains, safety curtains outside the operator area, so you need not go inside the area. When he goes inside, for any reason, something is not placed, the machine will stop. That interlock we have provided. So with this, all these systems we have completely integrated, and we verified the cycle time. Now it is again as 45 seconds, we have gone up to 44 seconds. See, earlier in grey cast iron it was 45 seconds, now it is SG iron, it is 44 seconds the cycle time. So our cycle time gone back to 44 seconds, capacity which was dropped to 120 in a theoretical, so it's back to 225, and EA index, it was 8553, we have got back to the normal index. So floor space is also optimized because we have compacted the area, and cycle time reduced to the plant level, safety is ensured for the operator. So our theme is Koi Manzil Dur Nahi, means no dream is too far. So everything is possible when you think, when you strain to a level where you have set the target. As one of the speakers in the beginning has told, you set the targets and achieve against the target. So then you can do that. So this year's our theme is Koi Manzil Dur Nahi, no dream is too far. Thank you. Pardon? Yeah, sorry. Thanks for reminding. So here one cycle is going on, operator is placing the sleeves for the next cycle. Because of the video shooting is a little bit, our hero takes multiple takes in the film. Like that he is also afraid, a little bit nervous. He forgot to remove these gloves, he is taking away. I have taken. So these, you see on the top side there are sleeves already placed. The die coating has happened. Now it is going inside, pre-positioned and inside the line. So the activity is over. All sleeve loss placed less than 5 seconds. Now this is in pre-position still. Now you have ample time, whatever you want to do it, you do it. That activity is over now. It has come to the home position now. Now he is pressing a cycle start. This will go up. He will start placing the next sleeves. He has enough time. So one cycle is complete now. Yeah, that's all. Thank you.
Thank you, sir. Thank you. Any questions?
One question on not on the main subject, it is on EEI index.
Yeah.
Everyone can listen to you, sir.
The question is on EEI index, how it works, how it get calculated.
Yeah, normally you must be aware in industry, we have something called as most Mayanas operating systems and techniques, which is used for calculating the operator in a scientific way. It is a very old tool, but in a scientific way you calculate all our operator movements and the time taken for those movements, including the bend, twist, turn, walk, everything is calculated in a scientific way. So one of the biggest advantage with that tool is you negotiate with the union without any bias. Union is very much 100% aligned if you do with the most. So that is for the standard IED cycle times. Similarly, we have arrived at, when we found out in sometimes back in 2013-14, we found out that most alone is not sufficient. Because there are some repetitive tasks which operator is getting strained. One operator is getting strained, other operator is not getting strained at all. So there should be a parity among these activities among the operators. So we found out that there is something called as effort taken by one operator is more than other operator. Similarly, ergonomics. Ergonomics means nothing but a repetitive task he is doing with the same whatever is the effort. So ergonomics has to be taken into consideration. Let us do a scientific way of calculating this efforts and ergonomic index. So there is a standard with which we arrived internally. So we have also used standard tools available in the books also. So we have, for each of these activities, we have found out an index in Ashok Leyland. It's internal to Ashok Leyland. So if you see that when you calculate as per this thing, anybody can calculate, you will get the same value. So that values will indicate to you what is the allowable limit and where we should be. So this is purely internal to Ashok Leyland, and some of the OEMs in bigger auto industries also they have used it. So I think it can be deployed into a little bit bookish knowledge. We can deploy in any industries also. I think it will be better for Foundry industry to have that as a norm and work on that, because the future is going to be, we want to attract more talent towards Foundry. That needs to be the need of our to make the work simplified as the regular manufacturing process industries. It will be, enable it better way.
Thank you. Is it possible to share the formulas?
Some of the inputs we can share definitely, as you are being a supplier to us, and some of the people definitely we will try to help out in this.
Okay,
sure.
Thank you.
Thank you.
Chapter chairman is expert in most studies.
Thank you, sir, for an excellent presentation.
Support.
Oh, any other question? Otherwise, yeah.
Excellent presentation. And these sleeves, we have seen, we do use the sleeves actually. But how do you overcome the moisture problem actually? Actually, do you preheat the sleeve before placing it into the mold, or?
We have
basically these sleeves are hygroscopic nature. It will absorb moisture from this one, no?
Yes.
So we actually before keeping the sleeves into the mold, we pack it in the airtight this one. Before that, we just open it and then place it.
Exactly.
But
We do
in the
that.
video, you actually keep it open.
Not much of time.
Yeah.
You answered yourself the question.
So
we don't keep it for much open. We have a very good conservative room where we keep it inside.
Okay.
We just open just before the thing and all. There are trolleys with a packed condition ready. We will open only when it is required, and we will not be using it.
you don't preheat the sleeves?
No, we don't preheat.
Right.
It's in packed condition only we'll use.
Okay.
Any more questions?
The cost when we compare with the robo, is it lower or?
It is lower. To answer you, yes, it is lower. Reason being, say, robo is not robo alone. Robo, end effector, and the area which occupies. So when the area is occupied more, first of all, it is not feasible for us. If you want to say where there is a place available and you want to still use robo, the maintainability of the robo is another activity. You have to take all those costs into consideration. And the solution in the integrator with the solution with the end effector, it will be lower. This automation will be lower or at par than the robo. We have used all aluminum structures because this load is nothing. We have used aluminum structures, there's a prefabricated aluminum structures and pneumatics, everything we have employed here.
Thank you, sir, for an excellent presentation on showcasing how to approach a problem and bring out solution to achieve the aim success. We extend a request to our chapter vice chairman, Mr. Vignesh Ramanan, to felicitate Srikanth sir with a traditional Angavastram. We invite Mr. Praveen Prabhu, MD Sri Akila Castings, to present a memento to our esteemed speaker. Thank you, sir.